Now, what are the different energy sources are generally used in case of welding processes? So, of course, the energy here is used to produce the bond in the form of the heat, first making the heat, application of the heat to melt the metals, and then cooling of the metals through solidification process. So, here we will try to what are the different categorization of the heat source maybe we used for the fusion welding processes. So, first is the electrical sources. Of course, we use the electrical energy either available in the form of the AC alternating current or in the form of the direct current sources. For example, the different welding processes, arc welding processes, resistance welding process, electro slag welding, all the different welding processes, we just use the source, we use the different electrical sources to create the thermal energy. Second is the another source of the energy for the welding is the chemical sources. So, here the chemical energy is stored within a cylinder, and in the different form we can use the chemical energy. For example, the oxy-fuel gas welding. So, oxy-fuel gas welding we can use the fuel cylinder and to make the gas welding processes, even for thermite welding processes. In this case also, that we can use the chemical energy, and of course, we use some in this case we use the thermite as a mixture of oxides and other materials, and that creates some chemical reaction, and that reacts that exothermic reaction, and that creates some amount of the heat, and that heat can be utilized for the welding purposes. So, in these cases the chemical sources actually acts as a to produce the generated heat. Optical sources, we can categorize the optical sources in this way, that fused beam of the electron or laser which is actually operated according to the law of optics. So, in this case that it can achieve a high power density, it creates it is possible to the high power density, that means a high concentrated heat can be possible as compared to the other welding processes. So, typical example is the laser beam welding processes and electrical beam welding processes. In these two cases, we can use the heat source from the optical sources. Then mechanical sources, the involve the some amount of the mechanical movement of the movement that actually produce the amount of the energy. For example, friction welding. If you friction welding, basically if you try to give the mechanical motion of the substrate material and the high rotational speed, then even if it is contact with the another material and that at the contact surface, there may be the generation of the heat due to the friction, and that friction happens due to the mechanical motion of the substrate material. So, in that way, that some mechanical source can be used to generate the amount of the heat. So, that is friction welding, ultrasonic welding and explosion welding, all these kind of welding processes, the mechanical source is the actually produce the amount of the heat. Solid state sources, we can separate category the solid state sources. In this case is the it is categorized by a lack of the motion in contrast to the mechanical source, which that is in that sense we are not using the any mechanical sources here, or maybe we do not use the mechanical motion as a source of the generated heat, but rather in this case maybe the application of the concentrated load or maybe distributed load is applied, and that is responsible for the joining of the material. So, that is one example is the diffusion welding, and in this case maybe the source of the energy can be considered as a solid state source. Now, when you analyzing the different energy sources is required for the welding process, now we will look back to the what are the different physical properties of the material and which may be significant in very specific to the welding processes or to analyze the different welding processes. So, physical properties basically of the materials influence the applicability of the different various joining processes. So, that is why we need to know the different physical properties of the materials, and that actually decides or that actually relates to the applicability of the different welding processes. So, that is why it is necessary to analyze the different physical properties of the metals. First is that electrical resistivity. So, electrical, it is having the maximum effect in the resistance welding and significant role in other processes like gas metal arc welding processes or gas tungsten arc welding processes. So, that is why we should know the what is the electrical resistivity of the material to decide the applicability of the different welding processes in principle. Thermal conductivity. So, what way the materials can transport the heat, that depends on the thermal conductivity. So, for example, some materials is having very high thermal conductivity, for example, copper is having high thermal conductivity. So, sometimes it is very difficult to weld, in the sense the application of the heat immediately the conduct away the amount of the generated heat. So, concentration of the heat is is probably less in this case to melt the material. So, that is why it is necessary to know the thermal conductivity of the, it is a very significant parameter that decides the applicability of the different welding processes. So, in general pure metal is having good thermal conductivity, but if we try to if we add on the alloying elements, generally the thermal conductivity reduces. Next is the coefficient of expansion. The thermal expansion coefficients in welding of the materials also is equally important to analyze the distortion of the welded specimen, because the application of the thermal energy, or there may be the thermal strain will be produced, and the thermal strain is that amount of the strain is that depends on the distribution or expansion coefficient. So, or maybe if there are two different materials, there is a huge difference in the thermal expansion coefficients, probably in this case there is a difficulty of joining these two materials, or maybe the two materials having the similar range of the two dissimilar materials having the similar range of the expansion coefficient. So, probably in that case the joining will be little bit ease. So, that thermal expansion coefficient is another important parameter, and that directly linked to the distortion analysis of a welded joint. Specific heat, we understand the measure or amount of the heat content, or it can absorb amount, or it can store the heat. That amount is basically decided by the specific heat of a specific material. Ionization potential. So, different materials, the ease of arc initiation, basically when you try to do the arc welding processes, how easy we can create the arc and what way easily we can maintain, or the arc can be stable, that actually relates to the ionization potential of a specific material. So, to get a initiation of the arc easily, and we can stability as minimum as possible, ionization potential of the material is required in this sense. Metal oxides, of course, oxidation rate is another critical problem in the welding process. So, different materials, the oxidation rate are different, and the refractory stability, when this between the metal oxides, the stability of the metal oxides during the welding is basically affects the transfer of the heat from the any source, or it also depends on the different alloying elements of the parent metal. So, that is why it is very important to know the oxidation rate of a specific material, or the nature of the metal oxides, and when you try to weld when you try to select the any welding process for a specific material, it is necessary to analyze the metal formation of the metallic oxide. Just to give an example, that aluminum oxide, aluminum is having high rate of oxidation and easily form the aluminum oxide. So, that is why when you try to choose the welding process, we generally use the alternating current, AC current, such that it creates or it removes the oxide layer in the half of the cycle, and remaining time of the cycle time, it is the simply hit the material. So, in that sense the analysis of the metallic oxides is required